We are looking at the tool set for problem solving, and in particular, we are looking at the tool called visualization and imagination in problem solving. Now, visualization is a very important tool in problem solving, just like imagination. It is linked to another tool which we are not covering here in the tool set, and that is called X Factor, which we'll talk about it in the main course. Now, the visualization and imagination is basically helpful in terms of seeing your path through your journey, through your solution journey. So, very often you are bombarded with lots of information. Some of it is relevant, some of it is irrelevant, and the trick to solving the problems is to visualize or think, slightly out of box. Imagine, you know. Look at the problem in its multiple dimensions, in its multiple colors, so that you can see through your solution. Let's take a couple of examples. So the diagram shows a unit color cube. So there is a diagram which is for a unit color cube. Unit means basically the sides are of one length, a length 1 unit. Additional blue unit cubes are glued face to face to each of the 6 faces to form a three-dimensional cross. Now, this is where your visualization will come into picture. You have to visualize it as to you have to translate the instructions given in the sentence into a visual kind of picture. Yeah. So, what will this three-dimensional cross look like? If you see, basically, on this cube has got 6 different faces. On each of these 6 faces, you are gluing together another blue colored identical cube. Yeah. So this is what it will look like. There's a central cube which is not visible, and then each of the 6 faces is covered by a similar blue colored cube. This is something which you have to visualize, in your own minds, and that's where this art comes into play. Now, further instruction is, if the unit cubes colored yellow are now glued face to face to all the spare faces of the cross, how many yellow unit cubes are required? Now, in the first step, basically you translated this, you converted this single cube into a three-dimensional cross like this. It's very difficult to draw, and it's even more difficult to imagine and visualize, but that's an art which will be helpful in this tool. So you get this three-dimensional cube. Furthermore, on each of the exposed surface here, you have to paste another yellow colored cube. So all the exposed surfaces here should be glued with a yellow colored cube of unit length. Yeah, this is what it says. Now, finally, once you've covered all these exposed surfaces with yellow colored cubes, you need to find how many yellow cubes are required. Yeah. Now, this kind of problem, you have to the visualization tool or the imagination tool is basically is applicable wherein to solve it, you have to split this three-dimensional figure in your own minds into 3 different layers, into 3 different stories. So if you take it as 3 different stories of this building, uh, all the space spaces are to be covered by yellow. So the 3 different stories or the 3 different floors of the building will look like this. On the top, we have got a this particular unit cube. In the middle, you have got 5 cubes, the one which is the central, which was the original one, and then it is surrounded by 4 identical cubes on its 4 sides. And then finally, at the bottom, you have got one more cube, which is just the mirror image of what we had. These are all glued together to make a three-dimensional cross. Now, the point here is, uh, to all the exposed surfaces of these cubes, you need to paste your yellow cubes, and that's where your visualization will help. So if you look at the top layer, the 4 exposed surfaces are these. Yeah. So these two are exposed, which you will be covering it off, and then one again on the top surface is also exposed here, if you see here. And then finally, you've got 2 more surfaces which are to be exposed, which are left and right. So up and down, top, left and right. This is how you're covering all the five exposed surfaces of this top layer. Remember, the bottommost surface of the top layer is touching the second layer, so it is not exposed. Yeah. So then likewise, so if you count the number of yellow cubes required is 5. Likewise, the third layer is just the mirror image of your first layer. Yeah, the third floor is exactly the mirror image of your first floor, so you need not spend much time. You can just take a replica of it with the reverse polarity, and there will be 5 such cubes. Now the problem comes is in the central floor, because it's very thick, very heavy. If you visualize it, it will look like this, and the exposed surfaces around it is are the end points, the end ones, which are covered by these 4 yellow cubes, and then you have the intermediate ones which are covered by these 4 yellow cubes. Yeah, so these 4 yellow cubes are the intermediate one, these 4 are the end ones. Remember, the top surface of this floor is the top surface is basically is touching the is touching the upper layer. So the central one is touching the central one here, the blue one here, and these 4 are touching the already captured yellow squares in the top layer. So in all, if you look at the central layer, there are, if you look at it from a different if you visualize it from a different perspective, from a different angle, it will look like this: 4 and a 4. So in all, you have got 8. Now, with this, we have covered all the exposed surface of this cube or the three-dimensional figure with the yellow identical cubes. So the total number of yellow cubes will be the sum of 5, 8, and 5. Yeah, all the 3 layers individually, which is 18. Yeah, as you can see, it's a difficult problem, and the only way forward is to visualize it in your own minds. It's difficult to draw it on a piece of paper, especially while you're in rush. But then you have to probably close your eyes, think through the problem, visualize it as evolving from a cube to a three-dimensional cross to a further complex structure like this. So now let's take another example. The diagram shows a quarter circle with center O and a semicircle arcs with diameter O and OB. So this is a diagram in which there is a quarter circle with the center O and this diameter, and there are 2 semicircles with the diameter OA and OB. These are the 2 semicircles. Now the objective is to calculate the ratio of the area of the region shaded gray to the area of region shaded black. You need to find the ratio of area shaded by gray to the area shaded in black. Yeah, so now this seems to be a very difficult problem, because the gray region and the dark shaded region, the black regions, they are not regular shapes. We can't have a formula for it. Unlike a square or a rectangle or a circle or a triangle or a right angle triangle, wherein you know how to find their areas. These two are very irregular shapes. These two are not so it's very difficult to find a formula by which you can calculate this these two the areas of the gray and the black region and find the ratio. So which means you need to find something else. So what we'll do is we'll apply the universal law of problem solving, which is, if we can't solve the problem at hand, let's look for another similar problem that you can solve. Yeah, now fortunately, if in this case, if you visualize, this is where your visualization will come into play. If you visualize, you can't solve the problem you can't find the area of this shaded region right away. But fortunately, in this problem, you are given some quarter circles and semicircles. At least you can find the area of those semicircles and quarter circles, isn't it? Yeah, that's where we'll shift we'll shift our attention in solving other problem which is solvable, which is to find the area of this quarter circle and the semicircle. Now, what do we need to find the area of the quarter circle and the semicircle? You need to know the radius of the semicircle. Yeah, if we know the radius of the semicircle, then you can immediately calculate the area of the semicircle. Now, unfortunately, the radius is not given, which means in your solution journey, you are stuck at the very first point. You don't even know the radius so as to find the area of the semicircle, which means that's the time to make an assumption. So we'll make an assumption that the area of the semicircle is r, as shown here. The area of the semicircle is r, which means the diameter OA and OB will be of length 2r. Yeah. What next in our solution journey? The next is basically we'll make a table. Now that we have assumed the radius to be r, let's make a table. The table will look like this. We'll have a figure, and for that figure we'll find the dimension, and we'll calculate the area for it. So the first figure that we're looking at, the first regular figure that we're looking at is this quarter circle. The quarter circle, which is this large outer quarter circle. We know its dimensions. The radius is 2r, as you can see. OA is 2r, and because we know the radius, we can find the area. The quarter circle is 1/4 of the circle, so the area of the quarter circle is going to be 1/4 of the area of the larger circle which it is part of. So if you calculate, the area will be this pi into the square of the radius. The radius is 2r, and you divide it by 4. So the overall area of the quarter circle is pi r square. Likewise, shift our attention to the semicircles now, which is the other known figure. Yeah, in this case of semicircle, the radius is r. The radius is r, and so the area will be pi r square divided by 2, because it's a semicircle. It's half of a circle. Yeah, so the area. So each of the semicircles, this one as well as that one, is of area pi r square by 2. Now what next? Now we have solved the problem, solved a similar problem. We're not able to solve the we're not able to calculate the area of the shaded regions. Yeah, but we shifted our attention to another problem which can be solved. Yeah. Now we have to come back, use the problem that we have solved, and come back to solve the one which is at hand. Yeah. So which means we have to relate whatever we have gathered here to solving our problem. Yeah, and this is where your visualization will again come into play. If you visualize carefully, what we have done here is basically the semicircle. If you look at the semicircle, this semicircle is comprising of two parts. The first part is this shaded region, and the second part is this white region. Likewise, this semicircle is also comprising of two parts: the shaded region, the gray region, and the white region. And the quarter circle is comprising of four regions. There is this black region, the gray region, first white region, and second white region. Yeah. So let's use the problem that we have solved in coming back to solving the problem at hand. So we talked about these four regions. Let's call them as W, X, Y, and Z. Let's call them as so W is this gray region, uh, X is this black region, Y and Z are the two identical white region. Now let's rephrase our objective. What is our objective? Our objective is to calculate the ratio of the area of the region shaded gray to the area of the region shaded black. So our objective in terms of X, Y, Z, W can be expressed mathematically as to find the ratio of W is to X. You need to find the ratio of area of W and area of X. Now again, we to relate what we have done here, with the problem, the similar problem that we had solved. If you look at this quarter circle is the sum of the area of all these four regions. So we'll add another column here. We'll say that this quarter circle is basically the area of W, X, Y, and Z together. Yeah. And likewise, the semicircles. If you look at the semicircles, the semicircle. If you look at this lower semicircle, it is made up of two regions, W and Y. So its area will be W plus Y. and which is in turn will be equal to the area of the other semicircle. If you look at this semicircle, the vertical one, it is Z and W together. So it is equal to W plus Z together. Now this is where the next step is very interesting. The next step is where is what we call as the visual manipulation or visual jugglery. Yeah, we'll try to manipulate the images that we have and see where it takes. Suppose if I were to add the two areas W plus Y and W plus Z. Yeah, if I were to add these two regions, what I'm essentially doing is taking one semicircle, because W plus Y is this horizontal semicircle, which is of area pi r square by 2, and adding it to another semicircle, because W plus Z is the vertical semicircle. Again, it has area of pi r square over by 2, so it will be, yeah. Now what happens if I add a semicircle to another semicircle? I get a full circle. I get a full circle of area pi r square. Now coincidentally, this was a visual step, a visual manipulation step. Coincidentally, this area pi r square happens to be same as the area that you have derived for the quarter circle. Now it may appear to be coincidental, but they'll be designing the problem in such a way that if you are able to just do a bit of visual manipulation, things will fall in place. And that's what this is falling in place. This area of the sum of the two semicircles happens to be equal to the area of this quarter circle. Yeah, pi r square is same as this area. So what we can write here is basically this area pi r square can be written as W plus X plus Y plus Z. Yeah, so we'll take this and equate it to W plus X plus Y plus Z. Now this gives you a very important equation in your solution step. This gives you an equation which can be very easily solved. How will we solve? We'll cancel out all the terms which are appearing both on left and right side. So W from left is cancelled by the W on right. A very simple step in solving your equations. Likewise, a Y on the left will be cancelling out with the Y on the right. Z and Z will also cancel out, and finally what you'll get is just the W on the left hand side and X on the right hand side, which means it boils down to W is equal to X. When we say W is equal to X, what can we talk about the ratio of W and X? It means that the ratio of W and X is 1:1, which means the ratio of the area of the gray region and the black region is 1:1. Now, as you have seen, this was a very difficult problem. We shifted our attention to solving a similar problem, applying the universal law of problem solving. Then we applied the generic approach of problem solving. But the kick here, the boost here was provided by visualizing it as 4 different regions, doing the visual manipulation of adding two semicircles into a full circle, and finding coincidentally that it is equal to the area of the circle is equal, the area of the circle found by adding the two semicircle happens to be the same as the area of the quarter circle.
You have just seen a free sample video in which just one of the many tools in our problem-solving toolkit was practically applied to solve just one very difficult problem. To get even more benefit, please also have a look at the other videos available on a variety of problem-solving tools offered to you in our toolset. However, just watching these sample videos is like just glancing at the tip of an iceberg, whilst much more remains unexplored. It's like only watching the entrance of a gold mine without entering it, when the entire gold mine is available to you up for grabs. If you want your child to become proficient in solving hundreds of the toughest problems that any child in their age group will ever solve, anywhere on the globe, if you want these techniques, the entire problem-solving toolset, to become a natural instinct, then please sign up with YoungThinks. YoungThinks courses are available according to age group and will expose your young thinker to hundreds of such problems, till a point comes when these tools become an inseparable part of their brain's DNA, something that they will invoke automatically and unconsciously when they face a problem. For a moment, think of the mental and intellectual transformation brought about by such a course in your child. Think of the confidence your child will possess once they internalize the full Thinking Skills Toolkit. Visualize the attitude with which your child will approach their studies at school, including any subjects that they may find difficult at the moment. Think of the kind of adult your child will grow into, fully equipped with the Thinking Skills Toolkit. What kind of professional achievements can an individual who has the mindset of a problem solver reach? And to put it in a very crass way, what kind of earnings this individual who knows how to think and solve any problem will make? The success, once you achieve it as a problem solver, is not just restricted to maths or physics or subjects in your studies. It percolates to all walks of life. It makes you a well-rounded, confident, and complete individual. The fact that no school in the country, no tutor in the country offers it, makes Young Thinks courses a unique skill set to acquire. Now you may be wondering, who all have benefited from this course? The beneficiaries include 1. Child Genius National Finalists, 2. Prize and medal winners at National Maths Olympiad, 3. Children with IQs at par or above Einstein and Stephen Hawking, 4. Invitees of special summer camps at Oxford and Leeds universities, 5. National Team Maths Championship finalists, 6. Aspirants appearing in the entrance test to the best universities in the UK, including Oxford and Cambridge, 7. Achievers with the highest grades in GCSE exams. So don't hesitate. Register for the Young Thinks courses starting very soon and let your child make the most of them. To register, go to www.youngthinks.co.uk and click the shop page to find the full range of courses suitable for your child's age group. If you have any queries regarding the course, the registration, or the discounts available, it's best to give a WhatsApp call to the number appearing on your screen, or send an email to the address given here. Please do not hesitate to contact us and get the best possible advice. After all, the right course may transform your child's thinking and problem-solving abilities to a height that you can only imagine. Do not wait another day. Book your place before the registration closes, or contact us to discuss what is best for your child. We will advise you on the best options for you and your child, depending on your unique context.